Let's review simple and compound interest. In this example, we had $1,000 to start with that we were investing, and we were investing at 5% annual interest. Okay, interest rates in this unit are always given as annual interest rates. And we're going to look at what happens when you calculate simple interest versus when you calculate compound interest. So simple interest here, you can see the interest is the same every year. It's 50. Okay, you never calculate interest on interest. You only calculate it on the starting amount that you had, the amount that you invested, the principal. So on the $1,000. Okay, so every time we're adding 50. It's very simple. Compound interest, however, is calculating interest on interest. So we make $50 the first year, but then the second year interest is calculated by taking the new amount, including the interest, and then calculating the interest. So what's going to happen in this table here is really we're multiplying by 1.05. So we are getting an exponential relation here. When you're adding 50 every time, that's a linear relationship. So when you're adding something, it's linear. When you're multiplying by something, it's exponential. Let's look at what the equations would look like. Interest for 1 year is the principal times the rate, okay, which is 1,000 times 0.05, and we get 50. Okay, that's how we calculated this first number here. I'm working on getting a general simple interest formula. Okay, after 7 years, the interest is going to be 50 times 7, right? Or, in other words, 50 is calculated by doing 1,000 times 0.05, and then you multiply that by 7. So after 7 years, to actually calculate without using the whole chart, we would take 1,000 and add the interest. So that would be 50 times 7, or 350, and that's calculated by doing 1,000 times 0.05 times 7. In general, the amount after t years would be the principal, so that you have the initial amount, plus the interest rate, and the interest is calculated by doing P times R times T, which we saw up here. Principal times rate times time. Okay, where rate is a decimal, time is in years, P is the principal, A is the amount. So there's our formula for simple interest. We won't do a whole lot of calculations with them because simple interest is not very common. Usually we're dealing with compound interest. Compound interest, let's look at what the equation should look like. We know exponential growth happens when we were multiplying. Okay, we're repeatedly multiplying by 1.05. So if we just use our general exponential equation, A is the starting amount, it's 1,000. B is the growth rate, what you're multiplying your table by, so 1.05. But we don't use y's and x's. In this unit, we're using formulas with A for the amount. See, it's more intuitive to use A for amount, P for principal, okay, because we don't always start with 1,000. And then it's always 1 plus the rate as a decimal. And when we're growing money, we're always going to have 1 plus something. The rate is a decimal, okay, and it's given as an annual rate usually, and T is the time in years. Okay. But then we looked at, what if we're calculating interest more often than just 1 year? So if I scroll to my next page here, I'm just waiting for the annotations. I'm going to have to stop this for a moment.